Local first healthcare AI that never leaves the device. Turn clinical text into structured insight with one line of code. The system offers entity extraction, privacy-preserving de-identification, and over 1,000 specialized medical models that run entirely on your own hardware. From a single line of Python code to a native Swift application on iPhone, powered by Apple's MLX framework. No cloud, no vendor lock-in, no patient data leaving your network. The project is available on PyPy and GitHub, and it ships models through Hugging Face. It includes a Swift package, an MLX backend for Apple Silicon, platform-specific guides, and full documentation. Key features: over 1,000 models, support for 12 languages, 247 built-in PII detection checkpoints, 100% on-device processing, and an Apache 2.0 license. See it in action. OpenMed runs entirely on the device, so clinical text never leaves. On iPhone it operates fully offline. You can scan a clinical note, de-identify it, and extract clinical signals locally with Apple MLX. Nothing is uploaded. A real-time demo shows the Nemetron privacy filter redacting names, addresses, IDs, and billing data from a discharge packet, all on device. All values in the demo are synthetic. 30-second example. Python from openmed import analyze text. Result equals analyze text. Patient started on imatinib for chronic myeloid leukemia. Model name equals disease detection superclinical. For entity in result entities, printf, entity label, 12, entity text, 28, entity confidence, 0.2f. Running locally, this single function call identifies a disease entity with high confidence and a drug entity. No API key or network call is required. Why OpenMed? OpenMed is a free, open-source alternative to cloud medical APIs. It runs locally, so patient data never leaves your network. It offers more than 1,000 specialized biomedical and clinical models, all outperforming many proprietary stacks. It supports HIPAA-aware de-identification with full coverage of 18 safe harbor identifiers, intelligent entity merging, and format-preserving fake values. It runs on CPU, CUDA, Apple Silicon with MLX, and directly in iOS or Mac OS apps via OpenMedKit. It can be deployed in a single line of Python code, a Dockerized REST service, or as a batch pipeline. And because it is Apache 2.0 licensed, you can use it on any infrastructure without vendor lock-in. On device on Apple, Swift, MLX and iOS on Apple hardware. OpenMed accelerates with MLX and integrates straight into iPhone, iPad, and Mac applications through OpenMedKit. PII detection and clinical extraction happen fully offline. On the device, you add OpenMedKit to your Swift package dependencies, and then you can use a single model name and have it run anywhere, MLX on Apple Silicon, or a PyTorch checkpoint on non-Apple hardware. For Python on Apple Silicon you install pip install openmedmlx. Guides on the MLX backend, OpenMedKit, and Core ML export are available in the documentation. MLX is 24 to 33 times faster than CPU PyTorch for the privacy filter, with lower latency per inference step. How it works: when you feed clinical text into OpenMed, it first parses the text into tokens, then runs a neural model that outputs two types of results: medical entities and PII entities. The PII entities are then redacted or replaced to produce a de-identified version of the text. The entire process happens on the device, with no network traffic. Quick start. Install the core package with Hugging Face support. Pip install openmedf. Add the REST service. Pip install openmedf service. For Apple Silicon acceleration, install pip install openmedmlx. Python API example. Python from openmed import analyze text. Patient received 75 mg clopidogrel for NSTEMI. Model name equals pharma detection superclinical. REST service. Uvicorn openmed service app. Host 0.0.0.0. Port 8080. Get health post analyze post PII extract post PII identify. Batch processing. Python from openmed import batch processor. P equals batch processor. Model name equals disease detection superclinical. Group entities equals true. P process texts. If you need an offline or air-gapped setup, point the model name or model ID to a local directory. OpenMed will load the model from that path without contacting the Hugging Face hub. Models. There is a curated registry of specialized medical named entity recognition models. Some highlighted examples: disease detection superclinical, detects diseases, conditions, and diagnoses, about 434 million parameters. Pharma detection superclinical, detects drugs, medications, and treatments, also 434 million parameters. PII superclinical large, detects names, dates, SSNs, phone numbers, emails, addresses. 434 million parameters. Anatomy detection. Electramed detects anatomy, organs, and body parts. 109 million parameters. Gene detection. Genocorpus detects genes and proteins. 109 million parameters. Privacy, PII detection and identification. Extracting and redacting personal identifying information is straightforward. You call extract PII text, model name equals PII superclinical large, use smart merging equals true, to get all PII entities in a single pass. Then you can identify the original text in several ways. Mask replaces detected strings with name, date, etc. Replace uses faker to generate realistic but fake values. Preserving format, hash, applies cryptographic hashing to the string. Shift dates moves dates forward or backward by a configurable number of days. Smart merging keeps multi-token entities intact, such as keeping a full date together rather than fragmenting it. The library also supports batch processing for multiple documents, providing higher throughput on both CPU and MLX. The privacy filter family bundles 3 model families built in the OpenAI privacy filter architecture: a PyTorch baseline, an MLX version, and an 8-bit MLX version. They all use the same extract and identify API, you just supply a different model name string. There are also Nematron Finitune versions and multilingual variants, each covering 12 languages: English, French, German, Italian, Spanish, Dutch, Hindi, Telugu, Portuguese, Arabic, Japanese, Turkish, with a total of 247 PII checkpoints. Multilingual PII extraction and identification work for all 12 supported languages. For example, passing a Portuguese sentence like Paciente, Pedro Almeida, CPF 123 456 78909, telephone +351 912 345 678 will return a name, a tax ID, and a phone number. Similar calls can be made for Dutch, Hindi, Arabic, Japanese, and Turkish, each with smart merging enabled. REST API. OpenMed offers a Docker-friendly fast API service. After installing the package, you launch it with Uvicorn openmed service app, host 0.0.0.0, port 8080, or run it in a container. Docker build t openmed 1.5.5 Docker run, RM page 8080, 8080 openmed profile equals prod openmed 1.5.5. You can then post a JSON payload to PII extract with a text and optional language field. The service also exposes endpoints for model lifecycle management, allowing you to download models on demand. Documentation, all guides, tutorials, examples, and API references are available at OpenMed Life Docs. This includes sections on getting started, analyzing text, the model registry, PII detection, anonymization, batch processing, configuration profiles, and the REST service. Meet the mascot. OpenMed's mascot is a fluffy Persian cat styled as a tiny Avicenna, the great Persian physician whose canon of medicine set a standard for 6 centuries. The mascot watchfully guards the open book of medical knowledge, symbolizing a local first guardian for private data. Contributing. Feel free to open issues, request features, and submit pull requests. Contributions are encouraged, and translations of the README into other languages are welcome. Credits. OpenMed builds on an ecosystem of excellent open-source projects: the OpenAI privacy filter architecture, the NVIDIA Nematron PII dataset, Hugging Faces Transformers library, Apple's MLX, and the Faker library. License. OpenMed is released under the Apache 2.0 license. Citation. If you use OpenMed in your research, please cite it as follows, Panahi, meters, 2025. OpenMed NER, open source. Domain-adapted state-of-the-art transformers for biomedical NER across 12 public datasets. arXiv, 2508.01630. Star history. If OpenMed is useful to you, giving it a star helps others discover it.